Welcome back to Global Works TV. From centuries-old water-powered sawmills to cutting-edge European manufacturing facilities, we're taking you inside the world of professional timber processing. Join us as we explore how master craftsmen and modern technology transform raw logs into the wood products that built our world. Let's dive in. You know, there's something deeply satisfying about watching a craftsman work with traditional machinery, the kind of equipment that's been around longer than most of us. Today, we're taking you to a special place nestled in the picturesque Rhine Valley of St. Gallen, Switzerland, where time seems to move just a bit slower and the old ways haven't been forgotten. And meet Martin Mock, a sawmill operator who's keeping a dying art alive in Mädris, a small village tucked into the stunning landscapes where the Rhine River carves its way through the Swiss countryside. Now, this isn't your typical industrial sawmill with computer controls and automated systems. No, sir. What Martin runs here is a genuine throwback to how sawmilling was done back in the day. And I mean way back. NTHE, Rhine Valley region, has been home to timber operations for centuries. These alpine forests, with their rich stands of spruce and pine, have supplied construction timber since the Middle Ages. The area's abundant water power from mountain streams made it perfect for establishing mills, and the tradition of craftsmanship runs deep in these Swiss communities. Martin's operation represents a living link to that heritage. Walking into Martin's sawmill is like stepping through a time portal. The building itself has that weathered charm you only get from decades of honest work. Wooden beams darkened by age, the sweet smell of fresh-cut wood mixing with machine oil, and sawdust covering just about everything. But it's the machinery that really catches your eye. This is equipment your grandfather, maybe even your great-grandfather, would recognize. And at the heart of Martin's operation is a water-powered sawmill system. That's right, water power. We're talking about technology that goes back hundreds of years, refined and perfected over generations. The main sawing mechanism is driven by a massive water wheel outside the building. When mountain water hits those wooden paddles, it sets in motion a series of gears, belts, and drive shafts that power the entire operation. The sound is incredible, a rhythmic churning and clacking that's been the soundtrack of Alpine sawmills for centuries. NTHE centerpiece is what's called a frame saw, or in German, a Gattersage. This is old-school industrial power at its finest. Picture a large rectangular frame holding multiple saw blades, usually between 4 and 8 blades set parallel to each other. The entire frame moves up and down in a steady mechanical rhythm, driven by that water wheel outside. When Martin feeds a log through, those blades cut multiple boards simultaneously. It's mesmerizing to watch, the frame rising and falling, the blades biting into the wood, sawdust flying, and perfectly straight boards emerging from the other end. What makes this system so clever is its simplicity and efficiency. Unlike circular saws that waste more wood in the cutting kerf, these straight blades make thinner cuts. That means more usable lumber from each log, a principle that mattered even more back when every board counted. The mechanism that moves the frame up and down is pure mechanical genius. A crankshaft converts the rotary motion of the water wheel into that reciprocating up and down movement. No electricity, no electronics, just good old-fashioned physics, doing its job day after day, year after year. And Martin operates his mill with the kind of practiced ease that only comes from years of experience. He starts by selecting logs from his yard, mostly local spruce and pine, the same species that have been processed here for generations. The logs are rolled onto the feed carriage, a heavy platform that slides along rails, carrying the log through the blade frame. Martin has to judge by eye and experience how to position each log for the best yield. Every piece of timber is unique. It might have a twist, a knot pattern, or a taper that requires adjusting the cutting strategy. NTHE feed mechanism is manual but ingenious. Martin uses a ratchet system to advance the log forward with each stroke of the saw frame. As the blades make their downward cut, the feed mechanism stays locked. Then, as the frame rises back up, the ratchet advances the log just enough for the next cut. This steady, measured pace might seem slow compared to modern operations, but there's wisdom in it. The slower speed means cleaner cuts, less blade wear, and safer operation. You can hear the change in tone as the blades enter the wood, that initial contact, then the steady rhythm as they work through the log. Martin reads these sounds like a language. A change in pitch might indicate a knot or density variation. The smell of the sawdust tells him about moisture content and wood quality. This is craftsmanship in its purest form. Man and machine working together, with sensory feedback you can't get from a computer screen. Supporting the main frame saw are various traditional hand tools and smaller machines. There's a manually operated carriage positioning system, measuring devices that look like they belong in a museum, and adjustment mechanisms that rely on threaded rods and hand wheels rather than hydraulics or electric motors. Everything is built to last and designed to be maintained with basic metalworking skills. NTHE waste management system is equally traditional. Sawdust collects in bins below the cutting area, while bark and unusable pieces are separated manually. Nothing goes to waste in an operation like this. The sawdust might end up as animal bedding, the bark for mulch or fuel, and every scrap of usable wood gets salvaged. What strikes you watching Martin work is the deliberate pace and mindful attention to every step. This isn't about processing maximum volume or hitting productivity targets. It's about doing the job right, respecting the material, and maintaining a tradition that's increasingly rare. In our rush toward automation and efficiency, places like Martin Mock Sawmill remind us that the old ways had their own kind of perfection, sustainable, repairable, and connected to the natural rhythms of water, wood, and human skill. Now let's shift gears and head to a completely different kind of wood processing operation, the Glover Wood Furniture Manufacturing Facility. If Martin Mock Sawmill represents the traditional roots of woodworking, Glover represents the evolution of that craft into modern precision manufacturing. But make no mistake, there's still plenty of artistry and skill involved here. NG Glover has built its reputation on producing high-quality wood furniture that combines durability with classic design. Walking through their facility, you immediately sense the scale difference from a small sawmill. This is a full production operation, but one that hasn't forgotten the importance of material quality and craftsmanship. NTHE process begins with raw material selection, and this is where Glover's commitment to quality really shows. They work primarily with hardwoods, oak, maple, cherry, and walnut being their mainstays. These species have been furniture favorites for generations, and for good reason. These hardwoods don't just show up ready to use. They arrive as rough sawn lumber, often still showing saw marks and uneven surfaces. The first critical step in Glover's process is the drying and acclimation phase. Modern furniture manufacturers like Glover use sophisticated kiln drying systems, but the principles go back generations. Wood needs to be dried to a moisture content of around 6 to 8% for furniture use. Too wet and it'll shrink and crack after assembly. Too dry and it might expand in more humid conditions. NTHE kilns at Glover are carefully monitored chambers where temperature and humidity are precisely controlled over days or weeks. This isn't just about removing moisture, it's about doing it gradually and evenly to prevent defects like checking, warping, or case hardening. Some of the premium lumber might go through an additional air drying period before kiln treatment, combining old and new methods for optimal results. Once the lumber is properly dried, it moves to the rough mill area. This is where the transformation from raw boards to usable components begins. The rough mill houses what's called a straight-line rip saw, a powerful machine that trims irregular edges and cuts boards to width. That knot might be perfectly acceptable in certain applications but needs to be cut out for others. And next comes the thickness planer, a machine that's been fundamental to woodworking since the late 1800s. Picture a heavy cast iron frame with multiple rotating cutter heads, each holding several sharp knives. As boards pass through, these cutter heads remove thin layers of wood, creating perfectly parallel surfaces with consistent thickness. The sound is distinctive, a sharp singing whine as the blades contact the wood, mixing with the rhythmic thunk as boards enter and exit the machine. Modern planers can remove material incredibly fast, but operators still need judgment to avoid tear out in figured woods or snipe at board ends. And after planing comes the crosscut and ripping operations, where boards are cut to specific lengths and widths for various furniture parts. Glover uses precision table saws and radial arm saws for this work. These aren't your home workshop machines, they're industrial-grade equipment with massive cast iron tables, powerful motors, and safety features that would make OSHA inspectors proud. But the principle is the same as it's always been. A spinning blade cutting through wood, guided by fences, and stops to ensure accuracy. Now here's where it gets really interesting, the panel glue-up process. Many furniture components are too wide to come from a single board, so Glover creates panels by edge gluing multiple boards together. The boards are arranged for visual harmony. Grain patterns are matched, colors are coordinated, and pieces are oriented to balance any natural cupping tendencies. NTHE gluing process uses specialized equipment. Boards are coated with wood glue, typically yellow PVA adhesive or stronger polyurethane formulations, then clamped in massive hydraulic or pneumatic panel clamps. These machines apply even pressure across the entire width and length of the panel. After curing, which might take several hours, these glued-up panels are stronger than solid wood and more stable against seasonal movement. NTHE panels then move to the finish mill, where they're sanded smooth using wide belt sanders. These machines use abrasive belts several feet wide, removing material in precise increments to create perfectly flat, smooth surfaces. It's a dusty operation. The air handling system pulls away clouds of fine sawdust to keep the work environment breathable and safe. Next comes the cutting of joinery, the connections that will hold furniture pieces together. Glover uses a combination of traditional joints like mortise and tenon and modern techniques like dowel joints and biscuit joints. The mortiser is particularly fascinating to watch. It drills square holes using a combination of a drill bit and a four-sided chisel working together. The tenoner shapes the matching male part of the joint, creating projections that fit perfectly into those mortises. NFOR cabinet construction, Glover employs CNC routers, computer-controlled machines that can cut incredibly complex shapes with perfect repeatability. These machines represent the cutting edge of woodworking technology, but they're following patterns and principles that furniture makers have used for centuries, just with unprecedented precision and speed. Throughout the process, quality control is constant. Inspectors check dimensions, look for defects, and ensure every component meets specifications before it moves to the next station. This attention to detail separates quality furniture manufacturers from those just cranking out commodity products. NTHE finishing area is where the wood really comes to life. After final sanding, pieces receive stain if color adjustment is needed, then multiple coats of protective finish, typically catalyzed lacquer or conversion varnish for durability. Each coat is applied, allowed to dry, then lightly sanded before the next application. It's labor-intensive, but it creates that deep, lustrous finish that makes fine furniture special. Crossing the Atlantic to Spain, we find ourselves at the facilities of Grupo Losan, one of Europe's major wood products manufacturers. What makes Losan particularly interesting for our purposes is their investment in a complete Linck sawmill system. German engineering at its finest, processing Spanish timber for global markets, NNLINCK for those unfamiliar, is legendary in the sawmill industry. This German manufacturer from Oberkirch has been building sawmill equipment since 1866. Yes, you heard that right. They've been at this for over 150 years. When major lumber operations around the world want the best, they call Linck. The company's reputation rests on precision engineering, durability, and innovation in log processing technology. At Losan's Soria facility, the raw material is primarily pine, Pinus pinaster, maritime pine, and Pinus sylvestris, Scots pine, from the forests of central Spain. These species are interesting because they're adapted to harsher, drier conditions than northern European softwoods, which gives them unique characteristics. Maritime pine can be somewhat crooked and knotty, presenting challenges that require sophisticated equipment to handle efficiently. Let's walk through the process, starting where the logs arrive. Soria sits on a high plateau over 3,000 feet in elevation, surrounded by extensive pine forests. Logging trucks roll in daily, delivering logs typically 2 to 4.6 meters long, shorter than what you'd see in many North American operations, but optimal for Losan's focus on pallet production and packaging materials. NTHE logs are unloaded by a Senebogen material handler. Think of it as a specialized forklift on steroids, with a hydraulic arm that can grip and maneuver logs weighing several hundred pounds with precision. The operator places logs on the in-feed conveyor, where the Linck system takes over. And first stop is the Microtech 3D scanner. This is where modern technology really shines. The scanner uses lasers or cameras to create a three-dimensional model of each log, mapping its diameter, taper, curvature, and surface defects in seconds. This data feeds into Linck's optimization software, which calculates the best cutting pattern to maximize valuable lumber output. The computer considers hundreds of variables, current market prices for different dimensions, wood quality, knot locations, and determines exactly how to orient and cut each log for optimal yield. Next comes debarking. Losan's system uses a Valen cone debarker, a Finnish machine renowned for handling difficult logs. This particular model has 8 feed rolls, 4 of them powered, which grip the log firmly while rotating it against debarking tools. These tools strip away bark using a combination of pressure and scraping action. It's important to remove bark cleanly without cutting too deep into the valuable sapwood beneath. The bark falls away and gets conveyed to storage. Nothing wasted. It'll be used for mulch or fuel. Now the debarked logs proceed to the heart of the operation, the Linck profiling and sawing line. This is where German engineering precision really demonstrates its worth. The system can adjust its feed rate continuously between 30 and 100 meters per minute, depending on log size and density. Larger diameter logs move slower to prevent blade deflection and ensure quality cuts. The profiling head is the first cutting station. Based on the optimization system's decision, positioned blades make vertical cuts along the log's length, removing slabs from the sides and creating a squared or profiled cant. The profiling head can adjust on the fly, accounting for taper and sweep in each individual log. Watching it work is impressive. Logs enter round and emerge shaped, with sideboards falling away on conveyors. Following profiling, the cant, the squared center section, enters the gang saw, a Linck multi-blade circular saw with fixed spacing between blades. This machine is pure power and precision. Multiple circular saw blades, mounted on a single arbor and spinning at high RPM, cut the cant into boards in one pass. The spacing between blades determines board thickness. Losan typically produces boards for pallets, so they're cutting to standard pallet specifications, usually around 18 to 22 millimeters thickness. NTHE gang saw is built like a fortress, massive cast construction to minimize vibration, heavy-duty bearings to handle the forces, and sophisticated blade tensioning systems to maintain cut quality. The sound is substantial, a high-pitched whine from the spinning blades combined with the deeper tone of wood being cut. But it's steady, controlled power, not chaos. And after the gang saw, boards travel via roller conveyors to the sorting system. This is where Kohlfass equipment enters the picture. Kohlfass, another German specialist, manufactures sophisticated lumber sorting and handling systems. The system at Losan can handle boards from 2 to 4.6 meters long, 70 to 250 millimeters wide, and 17 to 120 millimeters thick, covering their entire product range. NTHE sorting process combines automated scanning with strategic decision-making. As boards pass through, scanners measure dimensions, identify defects, and grade quality. Based on this assessment, boards are automatically directed to appropriate bins using transverse discharge conveyors. High-grade boards destined for furniture or construction go one way, pallet-grade material goes another, chips and low-grade pieces head toward particle board production. What's remarkable is the integration. The Linck sawmill system talks to the Kohlfass sorting system seamlessly. Data from the initial log scan flows through the entire process, tracking each board from log to final sorted stack. This level of control and traceability was unimaginable even 30 years ago. NTHE facility also includes substantial material handling automation. Boards are automatically stacked, banded, and prepared for shipping or further processing. Forklifts and automated stackers move product through the facility efficiently. The whole operation is designed for minimal manual handling and maximum throughput. Losan's investment in Linck technology represents a calculated bet on quality and efficiency. They're competing in tough global markets, and having equipment that maximizes yield, minimizes waste, and ensures consistent quality gives them a crucial edge. When the machines were commissioned, they brought in German technicians to oversee setup and training, a smart investment that ensures the equipment performs as designed. Our final stop brings us to the Pfeifer Group, an Austrian timber powerhouse that represents fully integrated modern forestry and wood processing. Founded in 1948 and now in its third generation of family ownership, Pfeifer operates across multiple countries and produces an incredible range of wood products from logs to finished engineered timber. And let's focus on one of their sawmill operations to understand how a modern integrated facility works. At the heart of any Pfeifer sawmill is the log yard. Logs arrive from sustainable forests. Pfeifer emphasizes certified sources and responsible forestry practices. In Austria and Germany, they're processing primarily spruce and pine, the workhorses of European softwood lumber. And from the yard, logs move to the sawmill proper. Pfeifer employs various sawing technologies depending on the facility. Some locations use traditional frame saws, similar to what we saw at Martin Mock's operation, but scaled up and partially automated. Others use band sawmills or circular saw configurations. The choice depends on the typical log size, desired products, and production volume. One common configuration is the bandsaw head rig, a massive bandsaw blade. Picture a continuous loop of steel several inches wide with teeth along one edge, cuts the log lengthwise. The log carriage positions the log precisely, the bandsaw makes a cut, the carriage repositions, another cut is made, and so on. Modern band mills can process logs incredibly fast, with computer-controlled positioning and laser guides for accuracy. And after primary breakdown, cants and boards move through various secondary processing steps. Edgers trim irregular edges to standard widths. Trim saws cut boards to precise lengths. Throughout this process, optimization is key. Every cut is calculated to maximize value. Higher grade clear wood goes toward furniture or finished carpentry. Structural grades head toward construction lumber, and anything not meeting lumber standards becomes raw material for panel products or fuel. NP Pfeiffer's integration really shows in what happens to the residuals. Sawdust, shavings, and wood chips don't pile up as waste. They're valuable inputs for other products. Much of this material feeds into Pfeiffer's pellet production. Wood pellets, those compressed cylinders of sawdust used for heating, have become major products in Europe's push toward renewable energy. Pfeiffer operates several pellet mills, processing millions of tons annually. The pellet-making process is fascinating. Dried sawdust gets compressed under enormous pressure through a die with cylindrical openings. The heat generated by friction, combined with natural lignin in the wood, creates binding, resulting in dense, energy-rich pellets. These pellets burn cleanly and efficiently in specialized stoves and boilers, providing renewable heating throughout Europe. NBUT Pfeiffer goes beyond basic sawmilling and pellets. They're major players in engineered wood products. Their CLT, cross-laminated timber production, represents the cutting edge of wood construction. CLT panels consist of multiple layers of lumber, stacked crosswise, and glued together under pressure. The result is incredibly strong, dimensionally stable panels that can be used for floors, walls, and roofs in multi-story buildings. And manufacturing CLT requires precise coordination of multiple processes. Lumber is kiln-dried to exact moisture content, planed to precise thickness, finger-jointed to create long lengths, then assembled into panels. Large hydraulic presses apply tons of pressure while high-tech adhesives cure. The panels are trimmed to size using CNC equipment that can cut openings for windows, doors, and utilities with millimeter precision. Similarly, glulam production takes smaller pieces of lumber and creates large structural members. Imagine taking 2x4s or 2x6s, gluing them face to face, and compressing them to create beams that can span large distances. Glulam beams can be straight or curved, sized for any structural requirement. They're stronger than equivalent solid timber because defects are distributed throughout rather than running continuously, and they're more stable with less warping or twisting. Then watching Pfeiffer's operations, you see how far wood processing has come from traditional sawmilling while still respecting fundamental principles. The wood is still the star, understanding its properties, respecting grain direction, managing moisture content. But the tools have evolved from axes and pit saws to computer-controlled processing lines. The result is efficient use of forest resources, quality products, and economic sustainability for rural communities built around forestry.